Hi, welcome to the RCM Handbook's Guide to Predictive Maintenance and the significance of the P to F interval. We will explain what predictive maintenance is, when you should use it, and how to determine the all-important P to F interval. Some assets fail randomly or suddenly, but many assets degrade predictably due to use, age, and wear. Some assets, such as cured rubber hoses, have an absolute life. We understand how rubber degrades in air. Fire extinguishers helpfully provide an expiration date, so we know exactly when to replace them. But many assets age in a less prescribed way. How quickly the asset ages can be due to how we use it or where it is used. Or the asset may have variability due to complexity or the nature of its components. So we may know that an asset ages, but we cannot say for certain how often it should be replaced or repaired. However, many assets provide detectable symptoms that a failure is about to occur. If we can measure the asset to detect such symptoms, and if there is enough time before the upcoming failure occurs, we can do something about it. We will be able to perform predictive maintenance. Predictive maintenance is performed on assets that age in a variable, but with measurements, predictable way. It involves measuring the condition of the asset and performing a corrective action if it falls outside condition limits. As such, it is often known as on-condition or condition-based maintenance. So what do we measure and where are the condition limits? To answer that, we must examine the asset's functions. Assets do not provide value by simply existing. They provide value by doing something. That something is its function. We must first determine all the primary and secondary functions of the assets we wish to maintain. Functions are the capabilities you require from the asset in a specific situation. It does not represent the asset's design or specification. We are concerned with how you use the asset. If we can quantify these functions, give them measurable values, we will have a measurable limit that shows when the performance is no longer acceptable. We will have a measure of when the function fails, the functional failure. This is best shown with an example. Imagine a chilled water system that is used to cool a power plant. In this system, we have a pump, our asset. The function of this pump in this system is to maintain a pressure of 1 bar. The manufacturer's specification states it can handle up to 2 bar, so this is the asset's capability. But importantly, our function limit is just 1 bar of pressure. If it falls below 1 bar, we have a functional failure. As the pump ages, its capability will degrade. It can no longer maintain 2 bar of pressure, but it can still provide more than 1 bar, the function we require. As it ages further, it will continue to degrade until it can't even provide 1 bar of pressure. We have hit our functional failure and may experience significant consequences. However, the pump's ability to maintain pressure, its function, follows a predictable pattern. Once it starts to degrade, it continues to degrade for a given interval until it reaches a point where it can no longer function. If that interval is large enough and we can detect the initial degradation, we can predict the upcoming failure and do something about it. The initial degradation indicates a potential failure. We are seeing symptoms that a failure is occurring or about to occur. To have a successful predictive maintenance strategy, we must be able to detect a potential failure. In this case, we can detect when we have a pressure reading that is below our operating pressure and outside normal equipment variability and measurement noise. After that initial degradation, failure is not instantaneous. We have a period where the asset degrades further with age until it reaches functional failure. This period, between the ability to detect a potential failure and the point when the asset fails to fulfill its required function or functional failure, is known as the P to F interval. So to perform predictive maintenance, we need two things: the ability to detect a potential failure and a long enough interval between detection and the functional failure. Such predictive maintenance requires two maintenance tasks: an inspection task to perform and record the measurement, and a corrective action task to replace or restore the asset before it degrades to functional failure. The inspection task is usually scheduled at a given interval, either based on time, for example once a month, or usage, such as every 10,000 miles. The corrective task is usually more involved and may require an experienced engineer, spare parts, or specialist resources. You may not be able to schedule the corrective task instantaneously. The P to F interval must be larger than the inspection interval and still leave lead time for the corrective action. Many modern assets provide their own measurements and can alert you when the potential failure has been reached. Or you may set up your own continuous monitoring system to do it. This is still predictive maintenance, but now the inspection task is automated and has an effective interval of 0. The P to F interval is still important though, as you still need sufficient time to schedule the corrective action. For further information, visit rcm-handbook.com.